Hi, everybody. This is Mr. Folly, and you better get your calculatrice out because your calculator is going to be your best friend. You're going to learn something today that you're going to wish you knew a while ago. So, equilibrium calculations. Determine K, given initial and final concentrations. Make an ice diagram using coefficients from your change line. Write the K expression, and which we do that already, and substitute the bottom line of ice into the K expression. So let's take a look. Find the equilibrium constant KEQ for the following equilibrium. The initial concentration of AB and CD2 are 0.6 before they are mixed, and when equilibrium is reached, the equilibrium concentration of AD2 is 0.2. So, you know me, I like to make sure I see my numbers. Use an ice table for your calculation. So, ice means I have an initial amount. Initial change equilibrium. Okay? Equilibrium could also be thought of as the end. So I'm going to read this again. The initial concentrations of AB and C2D are 0.6. The initial concentrations of AB and C2D are 0.6. Okay? Now, ice diagrams are always done in molarity. So that means if I give you moles over liters, you got to do moles over liters. Okay? But now if I told you that, that means I don't have any of these. Now, I'd like to point out that I've got solids here. Okay? Solids I don't really care about. Okay? So remember, whenever I do equilibrium, the only thing that changes, equilibrium is equal rates, so we're really only going to concentrate on our gases and aqueous. Okay? The equilibrium concentration of A2D is 0.2. So when I'm done, the equilibrium concentration is 0.2. So how much did this change? From 0 to 0.2, then it was plus 0.2. Now, if this was plus 0.2, this would be plus 0.4. This would be plus 0.2. And how did I get that? Looking at my coefficients. So 0.2, this would be double, right? But again, I don't care about my solids, right? This is 1. This would be double. So remember, reactants, oops, I said that one was plus. This would be minus. Reactants go down, so this is going to be minus 0.40. Okay? 0.6 minus 0.4 is 0.20. Okay? Again, we don't really care about the solids and liquids. Okay? We are looking for find the equilibrium constant KEQ. So whenever we have these, the first thing we do is an ice diagram. The next thing we do is write our K expression. K equals A2D over AB squared. So I have 0.2, A2D is 0.2 over 0.2 squared. Calculators assemble. And I have a calculator with no juice. So that is 5. All right. Determine the final molarities given K in the starting concentration. So final molarities means that's going to be my E line given K in starting equilibrium. So I'm going to write an ice diagram using coefficients for change and X for relative change. Write the K expression. We're good with that. Substitute the E line into the ice diagram and make sure they answer the question of which molarity do you need. So these are the steps on how to do it. So, okay, so first of all, you notice I was evil. I'm focused on my numbers, moles and liters. Arg. So that means molarity is moles over liters, 0.5 over 2. So that's 0.25. I'm going to use my calculator for that, 0.25 molar. And that's NO2. And O2, so that's O22. Calculate the equilibrium concentration if K equals 1.2 E negative 5. Okay, so ice diagram. Do. And molarities. NO2 is, what do I start with? NO2, I read that wrong. NO2 is placed in a 2-liter flask. There we go, so I have 0.25. And I don't have any of these yet to create these. 0, 0. Okay, checking to make sure it's balanced. 1N, 2 O's, 3 O's. Oh, for 2 here. 4 O's. And that one balanced, okay? So change is going to be minus 2x. Some amount, but I don't know what amount it's going to be. This is going to be plus 2x. Same coefficient, same change. Positive because it's a product, negative because it's a reactant, plus x. So at equilibrium, I have 0.25 minus 2x, and x. So now I'm going to write my K expression. K equals products over reactants, NO squared O2 over NO2 squared. Plug it in. K is 1.2e negative 5. Draw a line there. Equals NO, 2x quantity squared, O2 times x over 0.25 minus 2x, and this should make you about throw up in your mouth because it's so stinking hard. So here we go. Coolest thing you'll learn today. I promise. Coolest thing you'll learn today. I promise. Get those calculators out I told you about. Math. So you hit the math button and then up. Math up. And that will get you the solver. And you hit enter. Okay? So what you're going to have is it's going to say E1 colon E2 colon. Now this is if you've got the good calculator. If you have the 84 plus CE, which I hope you do. So equation 1 is the left-hand side. Oops. So I'm going to type in there 1.2 e negative 5. And E2 is going to be the right-hand side. 2x squared times x over 0.25 minus 2x. Okay, so I'm going to put that in my calculator now. 1.2 e negative 5. And then move to the next box, and it's quantity 2x quantity squared times x. So quantity x divided by quantity 0.2x. Well, wasn't it 0.2? Oh, I did that wrong. It's 0.25. I just wrote it down incorrectly. 0.25 minus 2x. Close quantity. I guess I have too many quantities, so I'll close that one. And then it's going to say x equals. And what we're going to do is if k, right here, is negative, we're going to put 0.001. And that's if it's a negative. E negative, that. And if it's E positive, we're just going to put 0.1. Okay? We should be fine either way. But what this does is it guesses on it. So what I'm doing is a super amazing like quadratic formula. Only your calculator does it all for you. 0.0001 alpha enter, and I got, it changed my x to the correct answer, 0.00887 molar. Okay, so let's see what the question answered. Calculate the ending concentrations of everything. Okay, we can do that. So 0.00887. So the first one was NO2. NO2 is 0.25 minus 2x. 0.25 minus 2x. So on my calculator, I'm going to quit out of here, do 0.25 minus 2x, enter, and I get 0.232. 0.232 molar. And then if I wanted to get, what was that one? NO, well, this was NO2. NO is just 2x. So I'm going to do 2x, enter, which is 0.0177 molar. And then what do we have left? O2 and then O2 is just X, 0.00887. Now, just because I had an answer key that has the wrong thing on it, I'm going to look and see if I copied my A down wrong. 1.2 e negative 5, 2x squared times x over 0.25 minus 2x. I know what I did. I forgot to square this. Shootsy tootsie. So I'm going to fix that in my equation. And guess 0.0001, alpha enter. I get 0.00555. So x equals 0.00, my bad, 555. All right. So then that would change all the rest of them to what the answer key says. So I made a little boo-boo, but that's okay. We'll have some grace, right? And some pity on the poor man. All right, so our final answers are what my little answer key thing says here, which would be O2. I don't know why I'm off by 1,000th here, but O2 was this. And then NO, remember, was 2x. And then NO2 was 0.25 minus 2x. And that's it. So I hope you enjoyed the solver. It is the best of the best. If you have a TI 84 plus, not CE, which is what I usually have, I will show you how to use that one in class. Toodles.